The art of computer graphics is only in its infancy. Only by computer could they be calculated and for the first time pictorially described.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
To be or not to be? That is the question.
Speech is still very complicated. Music is simpler.
Daisy, Daisy, give me your answer too. For the carriage, but you look sweet upon the seat of a bicycle built for two.
Howdy, howdy everyone. How's it going? You okay? You okay? Let's have a look at me. How do? How do? Welcome aboard the Skylark. Welcome aboard. Let's say something original. Let's think of something original to say. Hello and welcome to something else Amiga. That's not original. Someone else says that. Someone else says that. Okay, let's try and think of some original. Welcome aboard the... No, I've said that one. Welcome to something... No, I've said that one. Okay. How about if I just go on to this one? Howdy do? You okay? Crazy eyes. You want some crazy eyes? Have some crazy eyes. Alright, if that doesn't put you off watching, I don't know what will. Anyway. You okay? Right, we've got a bit of a mess going on here at the minute. We've got a mess this side and a mess that side. Let's see, I might have knocked the camera, let's just have a look. We've got a mess here. Probably knocked the camera a little bit. Let's bring it out. Bring it out. We've got a lot of mess here. Anyway, lots of cables hanging down. But if we go back to this one, we'll see the Days Retro Room sign has fell over. So let me put that right. Let's put that right. Hold on a second. Let's not try. Let's put old knacker cracker away. Can you see that? Yeah, just about. Oh dear me. Anyway, I don't care. I really don't care. Remember the Brooklyn Brawler in the wrestling? He came over to London or somewhere and started belittling the UK lot. And then they cussed him and he goes, I really don't care. Basically. Anyway. So, let's go and have a look at the thumbnail. Should have started off with that, maybe we did. Let's have a look at it. If I can remember how to do that, there you go. So, what we got today? We've got score, show and tell. Number 30. Upload speed is okay again. Went down on the last stream but one and we had to shut off early. So if you didn't see the last stream, have a look at that because that's really the stream that should have gone out. But anyway, so we've got score, show and tell. So I'm going to show you the score, or basically I scored what I scored. If you can call a score if you score something, traditionally you got it for cheap. Yeah, but anyway, didn't exactly get it for cheap, but I got it for cheap. The going rate. Let's say it was the going rate. Plus, some hidden things made it cheap. Anyway. So we're going to be doing a back panel G-code. So I've gone ahead and done some back panel plastic G-code. It's just the main back panel to do before I can go ahead and mill out the back panel. Okay. Anyway, so shall we do the show and tell? Let's do the show and tell. Ready? Well, we've got 2 show and tells, but let's just do the... Behind me, we've got this one here. That's an Amiga 600T conversion. That's an Amiga B2000. And it is a B2000. Somebody said, that's not a B2000. The B2000 was one with a parallel port sat on top of another one. I said, no. It tells you, actually says on the main board B2000. Haney Fisher. Revision 6. It says on it B2000. And I'll show you that. Let me show you that. Let's show you that. Let's show you that. A little bit of cake. If I can get it out. Can I get this out? Yeah. Right, so this board is not the board I showed you the other day. This is the board out of the score. The one I scored recently, if you can call it a score, having paid a lot of money. Anyway, so let's just show you what it says here. See what it says there? You can't see it. Let me try to alter it. Let's try and alter it. See what it says? Amiga B2000. Revision 6. Amiga B2000. So somebody said it's not a B2000. That's a different. I said I remember back in the day, my mate got one, so I know what a B2000 is. Anyway, right. So this one is dead. I think it may be dead, but it wouldn't work. And even when I set all the equipment that came with the score onto a new motherboard, which is now, I'll show you that in a minute. There. This one, this is the original board. It came with it only a few days ago. Anyway, it wouldn't boot up. Now the ROM in it, I think the ROM suspect. It's a revision 2.05 ROM, and it wouldn't boot up. So I put a 3.1.4 ROM in it, and then the hard drive. Can you see the cryptic comments? What a score! Quantum of Solace, a fireball from Fleabay, and 2 for the price of 1. That all means something. That does. It all means something. Anyway, I can put this down now, can't I? So you can see it says B2000. Right. So that's why I renamed Amiga B2000, because it is a B2000. Don't let anyone tell you otherwise, unless they prove me wrong, but I doubt it. Anyway, this is the panel. Look at that panel. 4 lots of plastic. And very shiny, and imagine that when it's built up. You're about to see all the stuff inside. And we haven't got a steel drive bay caddy. It's the same stuff, so you'll be able to see everything that's going on. Anyway, so this one's got to be repaired, and I think it's the ROM at the minute, but I've done no further tests and swap out the ROM. I'm going to put that back now because it's heavy. Right. So the score, what I scored the other day. Hello, Andrew English. Did you glue each piece together? No, there's no glue. Welcome to the channel, Andrew English. No problem. Now it's countersunk. If you use glue, it tends to run away, especially super glue. It makes the right mess. As in, I'll show you this sample. I showed this the other day. If I could get it out, that is. Right. This is one of my gadgets, and look at the state of it with the glue. Don't glue it. Oh, don't make a mess of it. I had to silicone it in the end because the glue broke. I fell on the floor and it broke apart. But that's something I milled out a while ago. Anyway. So this is my B2000 that I bought probably a few years ago now. I resurrected it, and it came with a SCSI controller with a SCSI hard drive. And the SCSI hard drive had a problem booting. It was boot, then it was clang. It wants probably service. So I put a Zulu SCSI in it and put all the cards back. It's got a 8 meg of memory on a card. No, it's got 4 meg on one card and 4 meg on with this SCSI controller. And that's all that's in there. This is the score that we scored on Fleabay recently. Now the case isn't as in good condition, it needs a good care, and it's a bit more yellowed. Didn't come with a keyboard, that's my keyboard for that one. But it works now because I put my other motherboard, my spare motherboard that was going to the plastic case, I put that in there only because I built it all up. Well, I took it all apart to clean it inside, find out what was working, what wasn't. And it didn't work, so I thought, well, rather than I need this board out to fix it, so I thought, let's put that board back in there and then I'll fix this one and I'll have this on the plastic. So that's what I did. Anyway, I'll show you the cards that came with it. It's pretty good cards that came with it, if I can find them. Oh, I can't. They're in here. I put them in there. But I'll tell you what's in there. There's a SCSI controller with a quantum fireball, hence the cryptic message at the start. Bottom tray piece handmade. No, everything is CNC'd. It's milled out of on a CNC, a Chinese 6040 CNC. I have an A2000 with a Dicky Olga. Oh right, yeah, that's an expansion. Yeah, 50 megahertz. Oh yeah, 60 megahertz. 128 mega RAM and M.2 support. Waiting for a ZZ9 to complete the Amiga. Wow, that's a lot of power. That's a lot of power you got there. Yeah, that'll be interesting. I'd love to see the outcome of that as well. Yeah. Yeah, I've got a Pi Storm to go in this one somewhere. Got a Pi Storm to go in this one. I've not even tested it. I've not even loaded the SD card, anything. I've not done anything with it. But that's going to go into my main one, or my test bed. So I don't know what you think about a Pi Storm, but anyway, I'd rather have a real accelerator. But at the minute, I'm happy to play the games with the 68000 stock. I'm not that fussed at the minute, but if we're doing anything like Wave or Sculpt Animate or anything like that, maybe we need something a bit more powerful. I also bought that one HDMI, Raspberry Pi to HDMI thing to go in the display port, so I've got that going on. Also got, I'll tell you what I've got, if I can get at them, they're a bit too small to reach. Let me just put you on to a different view a minute while I try to reach them. God, what is it? I don't know if I can reach them. I know, a ruler. Use a ruler. Let's grab a ruler. Oh, have a sneak preview of that while you're on. Yeah, look at this lot. Look what's in there. Can you see? Loads of ROMs and programmers, UV erasers, everything. It's crazy. Got lots of stuff going on here. It's all standard stuff. Running out of space again. Well, I'm going to try and get this board down because this one's a good one. If I can get it down. Can I get it down? Oh, yeah, nearly got it, nearly got poked in the eye by a ruler. Hang on. Now, I think this is the board. I've had this for a while now. So anyway, no, this is the wrong one. That's the wrong one. That's my project. That's me project. No, put that away. We're not doing that at the minute. So that's the wrong. I've got a couple of these boxes from JLC PCB. That's my main project, so I'll leave that alone for a bit. Right, let me try and get the right box. I don't know why it's come in a bigger box than. Oops, it's gone right over. Oh God, how can I get that now? Got it. There's one of me pick and place solder paste boards. Right. Okay, so what's in here? Oh, that's not it either. That's just a box of ESP32s. That's a box of. That's not it. Right, so where did I put it? Let's have a look. Put it somewhere. Ah, there it is. Right, here it is. Here it is. Right, this is good. This one. Wow, looks cool. These look cool, but I'm going to redesign this. These are PCB way, and I wanted one, and I wanted to reverse engineer it or get the KiCad file, but there we got. I think it's a copy of the Lviv. Just 2 megabyte chip RAM. So I've got the sockets and I've got the memory chip, and I've got the chip that does some kind of logic buffer. I only got one of those there, so I'll be building that. But to try it, I've got 5 of them. You have to buy 5. I had to buy 5. So I've got to build that up at some point. So that's another project to start off on the projects. So I've got 3 now that'll need to be upgraded to 2 megabyte chip RAM. But I've got ideas for that as well. So like I said, I'm going to make a new board. This will do for testing, but I'm going to put on there a ROM switcher. So we're going to have a board like that. So we'll have the 2 megabyte chip RAM. We'll have the ROM on it. Some places for ROMs to sit in. I know you can buy that chip that you can put loads of ROMs on. We maybe even use that, but what it's nice to do is just put a few normal ROMs in. Yeah, perhaps Diag ROM and 1.3 and then 3.1.4. Put them all in a row. Anyway, but what goes on it is one of those ESP32s, which is, can't see it. Can I show you down there? Yeah. So that one there. That's an ESP32 with this board I developed. That's for another project totally. But this idea, it's got a web interface which comes up onto your phone, right? So what I don't want to do, is it's okay with the plastic case because I don't mind drilling and putting switches in it at the back, but when you got your original, I don't want to be cutting holes. I hate to see a switch inside a drilled hole, you know what I mean? It's, even though one of my first Amiga 500 had 2 switches on the back, but so I'm going to keep them original, but we want some switches to be able to switch over the ROM. So that, what you do is I'm going to make this card that sits in either one of the spare Zorro slots, or it sits into one of the spare ESA slots that's not being used, something like that. And what it'll do is just take its power from the board and maybe the reset line. If I can find one with a reset line, that'd be nice. And then I'll just go on my phone web interface and I'll say I want this ROM switched on, this memory configuration, all that kind of stuff. But what it'll do is it won't switch it when you switch it on the phone. It'll save it, and you have to do a reboot, right? Because obviously you don't want to be switching stuff while it's powered up. So it has to. It'll do it once it reboots. You know, you'll have to be careful. You don't just switch stuff on. Well, that's okay. I can write to the memory, and then when it loads up, it needs controller will need to reboot itself. So every time. I need to hold the reset line low and all this kind of stuff. Just while it then loads itself up, but it's that quick. These modern microcontrollers are so quick. It'll beat the Amiga anyway, more than likely. Yeah, probably beat it anyway. So anyway, the web interface I've been designing for about 14, 15. Well, the software and the communication protocol for about 14, 15 years. The web interface since about 2018. And I got it into it's a nice thing, but it can easily be converted to switch, have an Amiga logo and all the rest of it, you know, and just you bring it up on your phone. And the only thing I was worried about was interference from the wireless module that's built in, but other people have stuck wireless modules in the back. I don't see anyone complaining about noise, but you've got to be careful where you plug it, because it's near the audio circuit. You might get some noise into it. So there's lots of that going on, but the main one, I got keyboards. I don't know if you can see this one. Underneath this, a bit took second fiddle. It's got everything on it. There's a keyboard there, and then you've got so this used to be a recording studio, hence the mics everywhere. Yeah, I've got mics everywhere, and I'm using one of the mics now. And I've got keyboards squirreled away everywhere, Korgs and all sorts of stuff. Guitars, I've had to move them all out because this room's been took over a bit by the Amigas at the minute. But I've been wanting to do the Amigas for a long time, but I've been busy on my project. So anyway, here's a score. That scored the other day. So got a bridge board as well. I wanted a bridge board, and I need an accelerator card. It doesn't have to be working, because I need to see if it fits in on the design. I've got to make sure it slots in. So this is a 386. The battery was a bit added there. I don't know if you can see that. See the battery. Still a bit left on it. I have to put a bit more vinegar on it. It doesn't look like it's broken any tracks though. It's only around the battery. So I've got to sort that. I've got to give that a go. Anyway, so I think I've covered everything there. So what I've got to do now is, in the background you can hear your ham radio on 40 meters. So I've got lots to do, but I want to, if you can imagine the main board. If you imagine going back to the main board, I'll just go over to this one a minute. Let's get over to the model. So here's the back plane. The back plane I've got to create a G code for. But if you're going back to that 2 megabyte, I haven't got it on here. I should put some chip sockets on here really. But you'll have the ROM, and then you'll have your Agnes somewhere like that. But instead of having one of those boards for the Agnes and one for the ROM, I'll make it so it just plugs in. You've got to take your Agnes out obviously and you'll have to solder that in, that piece. I mean, you may even be able to take your Agnes socket and your ROM socket out, and you literally, I don't know whether all the signals are available at the Agnes. I should imagine they would, but I'd have to have a look. But either a board that fits the whole lot, or one that just goes in the Agnes socket. It's got to be unsoldered anyway, unless you get. I don't like them ones that fit inside or over a chip, because that one there, that's an Amiga 600. It's got accelerator. It pushes over top of the CPU, and that was play it, then all of a sudden it'll go off. It's probably a dirty connection or oxidised. So I don't like the idea. I'd rather just solder it, unsolder it, solder this thing in place, and on top you can put your Agnes in. So you just put your Agnes into the socket, and then your ROMs into the ROM. You know, the different sockets for the ROMs, and you plug one of those little web interfaces on it. One of these web interfaces, I'll build that. It's only small, that part. You can build that onto it, and you just get to it on a web interface. You have some input-output on it, so you can run your flying leads inside to whatever you want to switch. You know, if you need to switch anything, rather than having a physical switch, you know, and the ROM will be switched with your phone. You'll switch ROM with your phone. You know, but honestly, you've got to reboot for the changes to take effect. It'll switch it in the software, then it'll save it, write it to a ROM, and it'll wait till the whole thing's been reset. So it won't just change ROM mid-flow. You know, you've got to obviously account for all that. Like, so anyway, right. So anyway, we'll get on with doing the back plate. So I'll show you what I've done so far. Back plastics. This was what I was on last time. I've done this offline. I did a bit of this offline, I think. Did I do this offline? Yeah, I think I did. Anyway, I've got this is all the back panel, the main back panel, and you've got the different packers and fillers for the Zorro slots, and the bay collar that the removable bay sits on. And right, so I've got the G code created for these already. Now this one I haven't got the G code for yet, so we can either do that now. Yeah, we'll do that now, I think. So basically, that's where I got to the other night. So just this last one, what I'll do is I'll create it in sections. I'm just going to check your audio. So we can either do that now. Yeah, the audio is okay. So this size here is my the size of my CNC bed. So anything bigger than that I can't make in one piece. That's why I've had to make the base plastics in 4 sections. But it came in handy anyway. I don't know if you've watched them other videos, but it came in handy. Right, so what I'm going to do this then. This has got a pocket. Show you in 3D. Hang on a minute. Right, so see that there? Let's go into perspective mode. Right. So this is 6mm piece of plastic, but to get your socket, your connector in, we've had to pocket this. So it's going to mill out this. It'll bring it down to 2mm. I think it's 2mm. Or was it 1.5mm? Can't remember now. Hang on. 1.7. Right, okay. I probably did 1.75. Right, so and what that'll do is it'll allow the socket to stick out a bit. And there's enough clearance to put your plug in as well. It's basically almost a copy of the real backplate. It's basically everything's in the same place, should be. So what I've got to do with that then, I've got to work out how many different, because on here, if you go like that, oops, not that one. See, some of them have got, not this one, let's go back to the, hang on, the base plastics. This is the base plastics. This next one, this is the G code for the base plastics. There's a lot more going on there. See, so the base plastics. That's what you got on the base plastics. That's the original model. Let's just have a look at that. So the base plastics. That's what that main board was sat on. It's got all the PCB fixing holes, and then it's stitched together. The fixing goes through there and stitches it through. So you've got two horizontal underneath and two going across, so it's like a laminated wedge, but when it's all screwed together it's one piece. And the reason for that is to get, I've got a hole milled out half and half that you can put a bolt through or a fix in, and down in here you'll put a nut in there, so it's encapsulated between the two, which allows me to screw the front panel to the base. Anyway, so on this one I got some of them, they only got 3 different G codes, some of them got 4. So let's go. I can show you the model quickly, unless you've seen it already. Right, that one's already made that G code. Right, so we've got this model here, so we can turn on some stuff. Say, let's put on so the PCB drive shelf assembly. So it's the drive shelf assembly. It's made out of clear polycarbonate. Well, it's not polycarbonate, it's acrylic. I think it's cast acrylic, not sure, maybe just acrylic. Anyway, so it allows you to see all the way through it, and that sits on this collar here that I've got to mill out. I've already done the G code for that bit, so that's a separate bit of plastic there, and then there's a separate back plane. Around the other side here, that's what it sits in, and then you've got 3 bits this side. No, 3 bits. So there's your back panel, and you've got your inner spacer, and then the last one is the Zorro slot part, and they all bolt together. Like. But I'll show you a quick. I'll put it all back together. I want it to put back together. It's just sometimes it's different. Trying to find all this stuff. Let's do it that way. I can see it coming back together. Right, ready. Right, here we go. Ready. Let's just put. I'll just go down the list. Right, so front panel, sides. No, I'll leave the sides till last. Inner front. We've even got the vent holes now in the front, and we've got a front shelf. So there's lots of doing the back first, but the feet, Zorro slots, Zorro cards. That's the Zorro cards. So we've got this is so we can get the size to do all this milling out for the slots, and then we've got I've got to get all the size right, so I've had to work all this out, and that's what these plastics are for, to sit that, and you even had to leave a gap for the bracket to sit in. Everything's designed in 3D to make sure everything would go together. If you had to design it each part by hand, you'd have to make each part loads of times unless you drew it. But the only thing I haven't got here is a full-size accelerator. So that's the size of an accelerator board, but the accelerator board goes all the way up to the plate and all the way back if you have a full-size one. And that's the only thing I haven't got. I've got all the other boards I can try in. I've even got a bridge board now, I'll show you that, and a SCSI controller, and I've got all these spare bits, but that's the only thing I haven't got. But the Pi Storm will just sit in there. Let's just get rid of the full size for it. Yeah, so the Pi Storm will just sit in that slot there. I haven't drawn the Raspberry Pi yet, so that's got to be done. Anyway, so everything's this thing. If you wanted to measure it, everything's exactly correct. Well, as far as I could do by measuring the actual item. So that's even to the clearance, even as far as the clearance here, like everything's there. Look. See, I don't know why I was a bit funny about putting a GoTech in here. And even thought about this item here, we could reduce that over a bit and put your GoTech here. But the first one, I want to make just a complete copy of an original one. And then after once we've got all the plastics done, we can alter that and make new plastic. So that front that can be taken off. You see, and the vents can be, some of the vent holes can be taken out. But you get a new appreciation for. Got a spare case, Rich 55. Do you know something? There was someone selling one for £105. Welcome. Rich 55. Oh, well, F Lock Slide. Lock Slide, how you doing? You okay? Yeah, welcome back. Yeah, Rich, I was trying to. I thought you was Mark 55, but I couldn't remember. I was going to message you on Fleabay. There was one, £105. I don't know whether you saw it now, and it was tidy case. I nearly bought it myself. I nearly bought it, but I don't know if it's still available. I don't know whether you had a look at that one. But I don't think there was a drive tray with it or nothing. It was just the case, I think. Yeah. So I don't know whether you saw that one. Anyway, let's carry on putting this. So I was just going to put all this. Let's put everything on so we can see where it is. HDMI card as well. I modelled everything to the size. I had to model everything to get the sizes. I was speaking to the seller. He was going to do a deal with the drive tray for me, but it sold before he had a chance. Anyway, Rich, I saved you. I saved you, Rich, from this one. I've saved you because the case is not that good a condition. It's nowhere near as good as the one. Let me just show you. The good score for cards and a quantum fireball hard drive on a SCSI, and you wouldn't believe it. It works. It works. It woke up after a while, but the main board is dead. The main board was actually dead. I think it's the ROM. I've got to power it up yet. I've got to get an ATX power supply and stick my adapter on it. So I've put my original board in this one. I got it working. But that's the case. It's not that good. It's tarnished. Plastic. You can't tell from here, but it's like smoke. You know, smoke on it, and the metal is all. I've tried to clean it. It's like tar on it. I've tried to clean it with IPA, but I'm going to need to scrub it, I think, with some kind of scourer. But it did arrive intact. It did make sure he packed it well, so I'll give him that. But that's got that bridge board out of it. There was corrosion on it, a little bit of corrosion, just there, a tiny bit, and then at the other side, I've got to do it again. I've got to take the battery out, but I don't think there's any arm done. We're going to have to inspect that under a USB microscope. I'll just show you this is the motherboard that came with that. And I've put the other dark green one in that and got it going. So I've got to fix this one. I thought I'll take it out while I got it in bits. And this is what it looks like. Have you seen that? Look how good it looks. That's just, you know what I mean? It just looks good. I like the imagine the whole case like that. The only thing is that plastic's not cheap. If you can get this plastic is reclaimed from when they used to partition the offices a few years ago. You know what I mean? I've got quite a few sheets of it for really cheap. But if you had to buy it, it's very expensive. So let's have a look at it. Lock slide, haha, smoked out. I don't know if it might be smoke, or it just might be the colour of it. But the case, it needs something doing. Unless, oh, you can't tell here. If I was to get a camera, probably there's scratches on it and it's grimy, but it won't clean with IPA. It needs something like a scourer. Probably have to be resprayed, but I don't know. If you respray it, what does that mean? Does that mean that you've give up on it? I don't know. Like my innards. Lock slide, yeah. Nice. I have been Rich55. I've been watching, just not been saying much. Yeah, no problem, mate. No problem. Yeah, that's all good. Toby Q, welcome, Toby Q. Is that cake? Is that cake there? Is that what you can see? It is cake. It's birthday cake. It's about a week old and it's a shame to throw it away. I hadn't got time to eat it. Anyway, maybe later. Oh, it's probably a smoke. You had it right. Yeah, maybe. Could be. Yeah, I once bought a microphone. I use it on my other rig, on my electronic lab streaming setup in another room, and that mic was totally full up of smoke. So I stripped it down and cleaned it all. It was a nice USB Samsung mic, and it works well. It's all right, like so. I got it cheap. Get it today. Oh yeah, what? Not my birthday, mate. Not mine. No, it's someone else's cake. Yeah, yeah. I gotta have my tea yet. It's boiling away. My soup is no way. Yeah, it's all good. This case, I mean, there's a lot of work gone into the case to model it. Crazy amount of work. So there's probably 85 hours, 80 hours, gotta be. Anyway, don't matter, but I needed to get the sizes, so everything had to be modelled. I could have got it from the 3D model warehouse, is it? 3D warehouse, but I don't want to sign in. Don't know. I could get it off there, but I wanted to measure what I'd got, so I don't know if someone. You don't know how much detail they've gone in to measure the size. So the only thing I got to go on is the real stuff. So yeah, one of them. So anyway, is there anything else to put back on this at the minute? So even left the CD-ROM discoloured, different colour, because that's what mine is. Mine's a different colour. It's a different colour. That's more that's mine's whiter than that. So anyway, so I'm trying to keep it as stock as I can at the minute. Is there anything missing? Inner front spacer, yeah, that's missing. All the fixings, the lid, and anything else? Plug-in connector, yeah. So I was saying I've got to pocket this out. Thanks to Rich55, he came and said, "Is there enough room?" And there actually wasn't enough room, so I've gone back and made enough room. But I had to model this connector just so I'd make sure there's enough room on top to get it in, and that's why we had to pocket that. So that's why we make a model of it, to make sure it's going to fit. I just lock slide. I just wanted to pop in for a sec. Still at work. Oh yeah, he's still at work. Sorry about that. Yeah. Oh well. Still at work. Here setting up phones. Oh, you know something? You won't believe this. We set up phones today. IP phone in Shrewsbury and Telford. Don't know if you know that one. Anyway, we set up IP phone there. A grand stream. I bet was yours or not? Was yours a grand stream? So can't have the video on talk soon, but no problem, mate. You come and go as you please. No problem. Your boss is watching you. Yeah, tell him it's work. So it's something to do with work. It's yeah. Yeah, nice one, mate. Take it easy. Yeah, my birthday not yet. Soon. Yeah. Anyway, so right, is there anything else to put on this? Front fixings. There's the fixings. So we've got two lots of ways of fixing it. Fixed from the back and tapped into the front plastic, or swap that over and put in the other way, so they're coming from the front and they're bolted through, but then you got the unsightly fixing holes, so we'll change that back. But this is only tapped into the plastic, so if you used to knock it, it might pull out eventually, and you've got to be careful what plastic you use so you can tap it well. Unless you, of course, you pocket it and put a brass fixing in it, glue it in or something. There's ways around it, basically. Yeah, there's ways around it. Anyway, while building this case from nothing, you have a new appreciation of the original designers of the case. I'd love to know who designed the case, because they have literally put the vent holes in the place. They've got holes. You can't see it. Let me just turn that off. Right, these big holes there. They go in between the Zorro slots. So the front grille draws in the power supplies on. It's sucking the air through here. It sucks it through these holes, and it sucks it along. Hang on, let's take the lid off. Sucks it along the inside of these cards, cooling the cards down. That's the idea. It'll go in, and then because there's pressure, I don't know, and then the heat will rise, and then the power supply will draw in and push it out the back. Push the warm air out the back. And them quantum fireball drive, that it gets warm. It does get warm. It's just the drive itself gets quite warm, so whether that's dragging a bit, it could probably do with the service. Anyway, so let's put all back together a minute. Is there anything left? So we'll have to model the new board that's got to go in, and the Agnes and the ROM switcher. I'm gonna have to model it just like one of my older models. I won't show you now, but of my circuit board, I modelled that to get it to be an intercom. Anyway, right, so just leave that there. Shall we put it all together? So lid, floppy disk. Got some floppy disks on top as well. Even modelled a floppy disk. Almost exactly right. So you could take that and turn it into G code and mill you out a disk if you wanted. Right, so back fixings and base fixings, that's it. Right, is that everything? Oh, sides, we haven't got the sides on. Sides. So yeah, everything's made of this same plastic, 6mm acrylic or polycarbonate, better if you got it. This stuff, it can crack, this acrylic. Hit it or try to bend it or tighten a screw up too tight, you can crack it, so you got to be careful with that. So anyway, oh yeah, let's put the let's get rid of the Pylestone, put the accelerator card because it has the back plate with it. So that's how it's put together with the stitches. But because I had problem with the base, because I had problem tapping it, every time I tapped it, the tap would actually melt the plastic, and when the tap was through here, the thread will get clogged up, so when you back off the tap, it will strip out the thread. So I had to try and clean the thread off, and then it didn't work out, so I ended up having to drill straight through and put a nut on the end. So luckily the feet just about clear the nut, the pan head, the nut. So it didn't quite work. It was all supposed to be flush, see? Supposed to be flush in there and not come out the bottom. So, but that is down to the material. So I'm going to leave it like that. But if it's okay to drill it straight through. If your material's no good for tapping, you can drill it straight through. Or if we find some brass fittings, I think you melt them in, don't you? That might be an idea, because this acrylic will melt. I think I've seen someone with a brass fitting and they've melted it in. They push. So if I make the hole to fit the brass, we'll have a look for some another day. I'll just put that on to-do list. Find some brass fittings and just melt them in, obviously without coming through the other side of it. And then when they're melted in, maybe they'll stay in and it'll be fine. Anyway, so that's that. I don't think there's anything else missing at the minute. No. On the pie storm. Oh, that joist, that bay there. Yeah, so that's everything what it is, with some extras. Right, okay, so I'll just put that there like that. Yeah, so that's the reason I've modelled it to such, so people know what it is you're making, and so I can get the sizes off it, so that's the main reason. Right, so let's get back over to the G-code. I'll create that because I've got to get my tea as well, and my cake. Go and get the cake. Right, so let's go back over to the back plastics. That was the one we're on now. Right, so I've done them. I can show you the G-code for that actually. Let's show you the G-code for them. Right, so I'm using a website called NC Viewer, and I can just go ahead and open. So back plastic, drive assembly, collar, plunge, outside cut. No, you want the inside cut. These are the 4 files so far. I'll just open them all up, and so that's going to cut out the plastic. This is the tool path for the CNC. Just run. You can run a simulation. It plots the holes where they attach to each other with the fixings, and it just goes round, jumps past the straights. That's it, finished. Right, so the next one is Zorro slot back left side cut. So there's an outside cut, so it'll just go round and do that. That's one part of it. So each panel's got 2 or 3 different cuts to do. Right, and there's the Zorro slot cutout. So you've got to cut them out first. Oh, it's plotting the holes that connect it to all the other, each part like laminated together. I'll just cut them out. And it's 6mm, and it'll do 4 passes at, I think it was 1.25 or 1.5mm a pass. Anyway, what's the next one? That one. So this is, that's the inner plastic, and the pots, the holes. So it'll plot the holes first, just takes the bit whatever you got in and plunges it through like drills a hole. Now it's doing. So that's, yeah, something slightly wrong there, but we'll leave it like that. So that's the last of that. So we're gonna have to. So that's these 3 here you've just seen. So they're done. So I've just got to do this one now. So how I do this then? I have to first make it. It's made it unique. So then I've got to put it sideways on. So come back into parallel projection. So this is it here. I've got to decide which bits I want to keep. So I want it, because I'm pocketing it. I need the geometry here for the lower half. So what I have to do is everything else that's on the top is on the bottom. So sometimes I take the bottom bit, sometimes I take the top bit. So what I'll do on this occasion, I'll keep the bottom bit, so I'll take off the top bit up to there, delete it, and that leaves me with just that bit. That's a problem now. I've got rid of my pocket, so that's no good, so undo that. Right, so I need this pocket. So I need to delete the top, but keep that line. So what I'll do, I'll grab this, I'll grab the geometry off this first. Right, so I've got that. Let me just make sure I've selected all of it. Yeah. Oh, there's a bit there. Bit there that I didn't select. Right, any more? Anything else? Any more? No, that's it. Right, so got to copy that. So I'll just copy it. And I'll paste it in place. Right, so that's telling me where my pocket's got to be. So we've got that. Now there's any more pocketing to do. There's no more pocketing. So really I can take a copy of that now. It's got to be there. It's difficult to do like this. What you need is an interlude. There you go, have an interlude.
The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds.
So, right, so I need to tell you what I'll do. We'll copy the whole thing. Right, I'm going to copy the whole thing down into this section here. Right, so because I have to work on it in stages, so let's go back as an overhead view. So what we need, we can get rid of that one now. Actually, that one we put there, we can get rid of it. It's not really got rid of it. Now we can split this up. So what we want is to mill out all these holes straight through. So we can do that from the bottom layer. Problem now. I've got two lots of. I'm seeing that one as well. So yeah. Tell you what, I can do it side. I can do it from the other way. Hang on. Is that the way? I can't remember. Right. So that's one way. No, that's which is it? I've got to get at it at the right angle. You see? That's not it. It's over this way. That's not it. Is it that one? Yeah. Yeah. So if I get it from that angle, that's fine. Right, let's just make sure that's the one. No, it's all this in the way, isn't there? Shit. Right, I'm gonna have to move it to. I'm gonna have to move it temporary to work on it. So I'm gonna grab that. I'm gonna move it over here. I'll just move it. Put it here a minute. Right, now I need to go sideways on. That's it there. No, I don't want the top bit. I only want the very bottom on this one. So delete all that. Let's have a look. Yeah, so that's that outline we want. So that's why we make a model of it, because we directly use it to create the G code to go on the CNC that cuts out, and it's because we've tried the model, all the pieces together. We know if the model works, then this is going to work. It's going to fit together at least. So yeah, it's just a bit monotonous getting rid of this. If you try and do, I've tried to do it other way by selecting it on a different, but then you end up selecting stuff you don't want. So it takes longer to unselect it than it does to carry on doing this tedious way. But obviously there's better tools for doing this. Normally paid for tools. That's the problem. I don't want to pay for stuff. If I was doing it all day, every day, and earning loads of money from it, yeah, you don't mind paying for something. But if it's just hobby stuff, different. Right, okay, oh, some more here. So basically what you're doing is flattening it with a pH. The tool that turns it into G code is called SketchUCam Flat Script. You put it into SketchUp, so like a plugin extension. and it'll turn. There's probably more available, but it turns it to G code. And you've got a lot of settings to set as well in the process. Right, oh, one more down there. So all I'm doing is just deleting. So we'll have a look around it, see if they've all gone. No, there's one more there, look, see it. One more. Right, now it's gone. So if it looks sideways on now, yeah, it should be flat now. Right, so that's all that. Okay, so that's what we want from that. So what we're going to do is we'll grab the whole thing again and move it back now. We're going to put it back, and we have to put it back precisely. So take that from the corner. Right, we've got to take it from the corner, and we've got to put it back here, top, aligned with that mark there. Oh, and it's crashed. It does that sometimes. So while it's crashed, don't know. While it's crashed, sing a song. Find someone on the radio. Yarnis, where's Yarnis from? Yeah, I have to wait now until it finishes crashing. It saves out and can't be helped. I thought it was the flat script, but then SketchUp does it anyway. So. Right, it's now crashed out, so I can start it up again. That's why I have to keep saving it regular. Does it a few times during the stream. Right, so back plastics. Save the changes. Auto save, yeah, load the last version. Right, so it's still there, it just didn't move it. Again, just carry on where you left off. That's it, so you've got to make sure it's spot on there, because on the CNC machine it starts from that point there. So I've purposely allowed 10mm and 10mm clearance. I've got a safe area. So this is almost enough to make it, but not quite. You can't make that because I can't apply an inside cut to that. So what I've got to do, I've got to grab as much geometry as I can. Actually, I could just do it like this. I've got to grab all this geometry and make sure I haven't got any of the edge, just that, and I've got to cut it, right, paste it in place, then cut it, then go back into it and then paste it in place. What that does, it fills out all the holes ready, and once I've done that I can explode the whole thing. Right, so everything's a separate entity now. So what I can do now is I've just checked my settings, have a look. Yeah, 6.2 thickness, 3mm bit diameter, multi-pass 1.5mm overhead gantry. Now the speed was a bit too fast, so last time when I did it I needed to slow it down, so let's just say make it a bit slower. Let's change, leave everything else where it is. Okay on that. So right, so this is the back panel. So the first one normally is an inside cut. So let's do if you're going to, the CNC's got to cut it out of the plastic. It starts out of a full sheet and then you clamp it down. So it wouldn't make sense to cut it out, an outside cut, because then you won't be able to hold it down to mill the insides. Turn that down a bit. So you have to do it in the right sequence. So what I normally do is the plunges first. So alright, that's a plunge there. All these are plunges. See, so I've just got to. This tells the CNC just to go to that point and just, like a drill bit, just drill straight through till it gets to 6.2 mil. The reason it's 6.2 and not 6 mil like the plastic size is the bed is slightly out, and I don't want to be getting the hand drill and trying to touch up by drilling through all the way. So you want all that taken care of for you. But in a minute, when I finish this, we can put it into the viewer and make sure that everything's what you expect it to be. Tool path, CNC's path is what you think. If not, then you have to redo it. So these are just fixing holes. So I'm just plunging them at 3mm. That's all I'm doing, plunging them at 3mm. That one doesn't like it, why not? You always get one sometimes that don't quite want to line up. Right. So the model, that's where all the holes are in the model, and that will make the CNC cut them out in the same place. So we've got all them, so I'll probably save that now. Now I can do the plunge and the inside cut on the same bit of G-code, so this is the inside cut. That's it, so I'll go one there, one there, one there, one there. You can even do these, and an inside cut basically uses the border, so the bit, if you used to measure that there, you should see 1.5 mil, somewhere there about, yeah. So the tool path for the bit, that blue line is the centre of the milling bit, which is 3 mil. So as long as your tool path puts the centre of that drill there, it won't go past this, and it doesn't matter about this waste, this size, it's fine. Anyway, let's carry on doing it. So we could do that one as well. All this got to be cut out. You don't have to cut it out if you don't want to, but one thing I didn't mention earlier, it was as well as doing that board with the web interface, I will also want to do a MIDI interface that fits into the spare slot. Yeah, if you're not using one of the slots here, you could put a MIDI interface in it. Right, so I think that's all on that one. So that's fine. So we could try that out. Let's put the safe area around it. The safe area will snap to, this safe rectangle will snap to these coordinates. So if I put it there, it's no good. It's got to go right there, and once you get within it, it snaps to it. Right, so now all I've got to do, I'll get a quick save. Just export the code now, and I've got to give it a name. So this is it's still the back plastics, and it's not the Zorro, so it's the back panel. So back panel, and it's not the back left anymore, it's just the back panel. So, and what we've got here is it's a inside, it's a plunge. Is that plunge or just, I can't remember. How did I spell plunge last time? Plunge. It's a plunge and it's inside cut. So you got to name it, otherwise you don't know what you're milling until you load it up. So it's the back plastics, it's the back panel, and it's a plunge and inside cut, so we can save that. So if we load up the viewer again. What was that? Don't know why I got a bleep then. Anyway, right, so we want that back again. Back plastics, back panel, plunge and inside cut. So we've loaded up that G-code we've just made, so you can see basically it's gonna plunge the drill where all them holes are. Does them first normally, and that's exactly what the CNC will do. It'll go through all them holes, it puts them all in exactly the right place. There's the actual code running. This is, when it comes to do these, in reality it's just skips the straights, this does, but in reality it would go across like that and turn around and go around about 4 or 5 times and then cut it through. And because it's acrylic and it can melt, I'm going to try a trick. I'm going to try some ice water and a spray, and I'm going to try and keep the plastic cool, because if it's cool, the milling bit has a harder job to melt it, so it cuts it rather than and then you can spray ice water on it, stop it, because it starts, the plastic melts like glue, it starts sticking to the milling bit. You can see there it's doing the holes for the phono connectors. Now this is only the hole in the middle, this isn't the pocket yet, because the plastic is too thick there, so it's got to be made thinner. Otherwise you'll never get your connector to fit in. You know, you can make it out of steel if you can, or aluminium plate. I might do one out of aluminium, 1mm aluminium at some point, but it's getting all the material, and then you wouldn't see nothing, it'll be in the case. But you could do the front and back plate out of aluminium, and then you could do the sides and lids clear and the base maybe. Anyway, that's just more of the same there. So while we're on a roll, we'll stop that and go back to there. Oh, it's just telling me the output file had finished. Right, so this one now, it needs to be the pocket. So what we don't want any other geometry now, because we've put it bottom left there, that's our coordinates. So this pocket knows where it needs to be on there. So what we'll do now, to do a pocket, it's very difficult to do a pocket. Like I'll show you a pocket here, and you have to tell it the percent. That's the pocket tool. Now it's on 33%. That's no good to us, because that's a third of the 6mm. We want it at 1.7, so it needs to be 1.75 thick. That'll give us a bit of tolerance, thick enough to not break off, but not too thick as you can't get your connectors in. So just about get away with it, and it's not too thin as on your bed that's not quite level, that it might get too thin and break through. So I've got to work out the percentage now. So the depth, so if you want to mill down from 6mm down to 4.25mm, you've got to go whatever 4.25 is percent wise of 6mm. And also got to bear in mind that we've told it it's 6.2mm thick when it isn't, just to cut, to allow for that. So we've got a little bit of tolerance there, slight bit of tolerance sort of thing. So what I've got to do now is work that out. I did have a tool somewhere that did it, but should be able to do it mathematically. Maybe we can just do it on a calculator. Let's try a calculator. Right, let's just try a calculator. So we're going to go. So we've got 6.2. Well, let's say it's 6 mil. 6 mil. And we want to leave. I don't know. Anyone good at maths? I'm useless at maths. We want to leave. So minus 1.75 mil. 4.25. Now we've got to find out what the percent are. Actually, it might have been on here. Currency, volume, length. Scientific. Was it volume? Length. Don't know. One of these did it. Teaspoons to millimeters. Gallons, no. Points, no. That's not it, is it? No, I think I did it on one of the browsers. Let's try it. Let's try it on here. So I want to do millimeters to percent. Right, percentage. Convert mil to percent. Right, so got a bit of noise going on here. Somebody keying up. Let's turn that off. Right. So millimeters. So 6 millimeters. Right. See, I don't know what this is doing. Convert. Oh, meridian to. No, that's not even the right one, is it? You've got to get the right tool. Milli to percent. Percentage. Oh, I don't know. I found it once. I just can't find it again. Percentage calculator. Right, go on and try that. Right, what is 50% of 80? Right, so if I go 6, and I want. Oh, it wants the percent. Oh, it's totally confusing. It's all this rubbish all around here. No wonder the world's gone mad. Look at all this taking your eye away from it. What is 50? No, can't. I found one that was great for doing it. Percent calculation. What's all this rubbish? What is 70% of? I want to know that. What is percent of? Right. What is percent of 6 mil? 6. 6 is what? I don't understand these things. Don't know what it is. Something is what percent of? Right, 1.75. Calculate. 29 point. Maybe it is. Ah, so that's. I want 4.25. 70%. So 78%. Let's say. Let's make that to a round figure. 70. So let's. 70.3. 71. 70, that's it. So we'll do 70%. That's it. That's all we need to know. Right, so 70%. So when I go on to this, right, I'm on this second one, aren't I? Right, if I go on to Pocket and I type in 70% and try and put this Pocket down over here. Ah, is it still a thing? Yeah. So what I need to do is I need to. That's the only Pocket. So what I can do is basically just I need to delete all this. Actually, I can delete all the whole lot, can't I? Yeah. So delete all that. Right, because all I want is That's the one out. That's the one on top. So I go back in. I delete all that. No. Oh. It's weird. Oh, is it still too thick? Hang on. Is it still? No, it's too high. That's why. It's too high. I need to bring that down to the level. That's higher, so I need it to be on the surface. So the way I do that is I'll have to grab it. It's not easy, so I'll have to grab that. Then I'll have to come at it with a bit of an angle. And I'll have to push it down on the blue axis down to this on the face of the component. That's it. So now it's flush. And now I can cut it now. Cut it. And paste it in place. So that's the pocket. That's all we want on that, the pocket. Don't want anything else. We might be able to do the outside cut as well. Let's try it. So that pocket. So if I'm gonna have to explode it. Explode it. So it's you've got these sections now. We don't want any of these sections. All the rest has been done. But that's the one we want. So we're going to go on pocket. We're already on 70% down here. So if I go like that, now it's going to create a tool path to create the pocket. That's it. So that's done for me. Now, what I need, can I do an outside cut while I'm here? Yeah. Right, so I only have to create 2 to do that whole thing. Right, so what we'll do now, just save that. I'm going to put the safe area around it. This is the safe area, is where the software will create the G-code based on whatever's in the safe area. Right, so I'll go over to that. Got to give it a new name, so it's going to be called back panel. It's not a plunge and inside cut, it's now a pocket at hang on, let's call it connector pocket, and it's got to have the percentage, so it's 70%. 70% of 6mm, and then it's also right. It's a connector pocket, 70%. It's also and an outside cut. Outside cut, so it's both. Right. Connectors pocket, 70%, and an outside cut. Right, so save that. So I've go over to. That's just finished it. Go over to have a look at it. So that's the other bit. We'll connector pocket and send outside cut. Right. So if you run that up, it should do the pocket first. You can see it's going up and down the tool path to doing the pocket, and it's going. You can see it's going 3 times instead of 4. It's leaving 1.5mm of panel left there. So it's now doing the outer edge. Oh, it must have finished. So go, if you run it again. Right, run it again. So it's doing the pocket. And when it's finished the pocket, it'll go around and cut it out. That's exactly what we want. So, yeah, once we've got that G-code, we could go over to the CNC, load it up, put some plastics down, clamp it down, and put the vacuum attached to it to hoover up all the pieces, and if I keep it cold and then put some ice water on it, I might be able to mill it out without it keeps clogging up the milling bit. Right, so anyway, so that's it. So we've done what we said we're going to do today. So I just need to now is go through the process. So now I've cut the plastic into this size already. So obviously one plastic, I can get that out of it. That, probably all these three, or maybe 3 or 4 out of the one sheet, and then the other sheet, because I'm not going to waste it, because I will just use. I could turn it round or set the CNC over a bit and use the other bit. So use it all up. Anyway, so that's that bit done. So next time you see, let's close that down. Let's just save it. So we've done what we wanted there. Let's go back to the model a minute. Right, so there's the model back, and so what we just created is all. Actually, if I go into this, if I go face style monochrome, you can see a bit better what we've created, what we're milling out. So we're milling out all this back plate. We're milling out a spacer that's in here, this spacer, and then this Zorro slot plastic, and we're pocketing that and cutting out all these holes, and the hole for the power supply. Well, this is not for the power supply, it's for the drive bay. And then there's the inside, so take the sides off. There's these inside plastic collars. Hang on, let's move the HDMI card so you can see this plastic bolts onto the front, and it sits there, and then the drive bracket, caddy, whatever you call it, sits on top of it. And I'll just show you something quickly while you're on how you get this drive out. So take the floppies off of it, and the lid, take the lid off. Right, so if you're wondering how you get the drive out, once it's all attached to this plastic, because it's sat in there. Let's go back to the normal view. So because it's flush in there, you've got to withdraw it out, and if you see, there's no way to withdraw it out because it's stuck in there. So what you do, I can show you this again. So basically what you do is you get your, select it like that. I've done this before, but I don't know if anyone's watching it. So you start off here and you go round to here. So the first thing you'd have to do is you lift up the back a little bit. See that? You lift it up a tiny bit, like enough to clear. So it has to clear that corner there, just there, has to come up and clear into that space area. Once you've cleared into there, you can then, if you go around the back, you can see it, you can withdraw it this way. So you can actually withdraw that plastic there. That plastic's part of the caddy that the power supply is bolted to, and that's slotted in to the other plastic. You can't see it too well, let's try it. Yeah, so that plastic is part of the drive caddy, and it slots into there. But you've got clearance now. Here should have clearance. Yeah, you've got clearance. And what you do is you draw it back. So you like that. You still haven't got clearance here. But what it'll do, it's hitting in this shoulder, and what would have happened? It would have rose up. It would have articulated up a little bit, about 2 mil. So it would be on this shoulder as you lift the back up, which is still not enough. Actually, probably 2 mils too much. Let's just go 1 mil. So what that'll do is it'll give you the clearance. Still got clearance underneath, still got clearance on top, and all you've got to do, you've got enough clearance now here. You've got clearance between there, that front post, and that one, to withdraw this back. You can't see it from here, but you can withdraw. You're out of the slot that keeps it in place. That's the slot there that this sits in, so it can't move around. As long as you've cleared this, I've gone higher than I needed to go, but as long as you've cleared that, all you've got to do then is just grab it. Once that back ends up, you just grab it and move it out 6 mil, right, which will bring it, the bottom piece, into there, and then the back plate of the power supply will be touching the back plastic, right, but then it should be almost clear of this. Yeah, you're almost clear of that. Now in reality you will be clear, but because you've got a bit more to go, and I've gone higher than I should have done. I've gone a bit higher there, so what I should have done was, if I'd have gone like that, I've gone too high, so it would have been something like that, right, which would allow us to go back a little bit more, say another 1.5 mil, right, which would make that just touch the plastic there. You can't go any further back than that, right, so, but that should be enough now to clear the front. Should be. Yeah, there you go. It's a tight fit, but I think it'll work. It'll work out. It'll work out, because and it should be able to push it out. If not, we'll have to adjust it and make a new caddy slightly. We want to keep the clearance here for the connectors. We could always bring that in and shorten it. We have to make a new plastic, but I think it'll be fine. So then once you've got it out, then the whole thing could be lifted up. Oh, yeah, the whole, hang on. So the whole thing could be lifted up, out, like that. So you're out, and then that assembly is still in one. The good thing is you can see straight through it. You can see through it. So you can see through underneath where the real one's metal. So that's what you. These are the shoulders it sits on. So that's the design. It might change a bit. So what I've got to do now is undo all this stuff. Right, so we're back to where we were. Okay, so I think there should be enough movement in it. And also, these only slot in. This slots into that, and gravity holds it in, and your power supply fixes to this piece. So you could lift the whole power supply out if you wanted. So you might have to put a retaining screw once that's got from underneath into that, just to hold it still. Or I'm not bothered, because I mean I'm going to lift it up and I'm going to put it down on the table. I'm not going to start twisting it, but anyway, we'll see how it goes. Right, so that is that. Anyway, oh, the other thing, these vent holes, yeah. There's going to be a lot of these vent holes cut out. So what I might have to do here, I'm thinking about investing one day in a laser. I've got a couple of laser K40 lasers, Chinese laser, but they only do 300 by 300. They don't do a wide enough piece. So I need one that'll do sort of 600. So I might see if I can sell those two and maybe get one that'll do a bigger area and more power. Because I'd rather laser it out than mill it out and then have to trim each one of these. It's a lot of work to trim. Go around, take the burr off. You know what I mean? So I think a laser is going to be essential on it. Laser router, laser router. Yeah, and also when we come to do these bits here, we might have to pocket them as well, because the screws won't reach. So yeah, there's more to do. Well, there's a lot more to do, but I want to get the back and the front plastics done as soon as I got the bottom part done. Anyway, so that's it for now. Right, I'll just give you another view of the plastics before we do one. What we've got so far. That's the base. I needed the base to work on it, and that's what it looks like. Looks very nice. Look at the shine on that. Brilliant, isn't it? Love it. And it's precise, exactly. The CNC I got is it's nothing compared to an industrial one, but it's supposed to do 0.04 of a mil accuracy. It's supposed to. It's got ball screws on it. It's a ball screw, so it's very, very good. Anyway, right, that is going to be it. So I'll leave you with. What shall I leave you with? That one, or can I either leave you with that one? Score. So the score was the computer. 2 lots of graph. There's 2 megabyte on the SCSI card. There's 2 megabyte on a dedicated memory card, and there's the exact same card again with another 2 meg, but there's 6 meg on each one unpopulated apart from the SCSI card. So anyway, yeah, so this case is in a bad way. I'm going to try and scrub it, but the other one's a lot better. Anyway, alright, that's going to be it. Okay, totally lost my track on everything today. Right, so let's go back to that. Right, say goodbye for now. I'm out of here, and catch you on the next one. Thanks for watching. Take it easy. Bye bye.
The computer converts these numbers into impulses that cause sound waves to come directly from a loudspeaker. The art of computer graphics is only in its infancy.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Only by computer could they be calculated and for the first time pictorially described.
Speech is still very complicated. Music is simpler.
To be or not to be? That is the question.
The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds.
Daisy, Daisy, give me your answer to the for the carriage. But you look sweet upon the seat of a bicycle built for two.